All right, so now that we have added the molecules, we have four molecules to interact with. Let's explore some of their properties. But before we do that, let me adjust the screen a little bit. There we go. So in order to do this, you just need to keep pressing the control button and then use your mouse wheel. Then you can zoom in and zoom out. Okay. All right, so first we're gonna focus on the bottom section, which is called parallel coordinate plot. And click the properties icon. It looks like a small checklist. You will see a list of properties you can explore, and many of these should look familiar because we already covered them in our homework. So let's do mass and polar surface area and density and boiling point. Next, click the data icon over here. It looks like a small spreadsheet. Then you can see a table that shows the values for each property listed for all the molecules in your gallery. So there are four molecules. And this is a very helpful feature because it organizes everything very clearly. And if you want to download this data, just click export CSV. And then you can open that Excel file just like this and explore the data even further, not just in Ames, but outside of it as well. Okay. Now that we know where we can see the property data and which properties that we can select, let's move on to visualizing using graphs. Okay, then let's take a closer look at the parallel coordinate plot, which is a powerful way to compare molecular properties side by side. In this section, you're going to see multiple vertical axes with many different lines crossing through them. Each vertical axis represents a different property like mass, polar surface, density, and boiling point, and we selected them here. And each line represents one molecule and its values across all properties. And now the plot doesn't look good, and there's a tool that can help. And it automatically adjusts the axis to fit your data better. And to use it, look for the icon next to the camera icon over here. You see that? Click it, and then your graph will resize to make the data easier to read. So I like this feature over here, and this is called auto scale graph. Okay, next, we're gonna try hovering over each property name. If you do that, a small pop-up definition will appear to help you understand what the property means. And you can also see the minimum and maximum values for each axis. And you can adjust it here as well. And now let's try clicking on a property. For example, let's click on mass over here. Click it. And this will sort the molecules in the gallery based on their mass values. And then sometimes we want to reverse the sort order, right? Then we just need to click this button over here that has an A and Z. Click it. And then we can see that the order is reversed. Okay. And then let's try deselecting all the molecules by clicking the checkboxes next to their names, just like this. And what you can see is the lines for those molecules disappear from the plots, right? And let's try selecting them again, one by one. So select this one, and you see the line over here. Select this one, and this one. And all the lines came back. This is helpful when we want to analyze only a specific group of molecules. Okay, and you can also click on any line in the plot to highlight it. Let's do this one. Then a dashed outline will appear to show which molecule that lines belong to. Yeah, so this one is methane because it has a dashed line over here. Oops, again. And this one acetylene, this one, ethylene, this one, ethane. All right, and if you want to adjust the property ranges manually and you want to do some filtering, and we can also do that too. Just drag the sliders on each axis, just like this. Then we can easily filter in and out the molecules. Let's try an example together. So on the mass axis, drag the small dot to only include molecules with a mass less than 20. So we drag this less than 20, just like this. And there's only one molecule that meets that criteria. And as you move the dot, you'll see which molecules get filtered in and out in real time. Okay, so we just explored one of the most powerful data tools in AIMS, and we're going to move on to the next feature, which is called scatter plot. Okay, we're going to next use a scatter plot to see how two different molecular properties are related. In order to do that, we're going to first click the gear icon over here. And in the graph type section over here, we're going to select scatter plot. Next, we're going to click the coordinate system icon over here. And here you can choose which properties you want to compare. For example, in this activity, let's use mass for the y-axis and boiling point for the y-axis. And once your chart appears, you can adjust the minimum and maximum values for each axis by typing directly into the boxes. So let's do x 10, 30, maybe 40. There we go. And minus 1. Here we go. All right. And the plot now doesn't really look great. It seems like the dots are randomly connected. So let's fix this by clicking the scatter plot settings over here and then choose sort by X. And now it looks better. And we can also adjust how the chart looks. So click the scatter plot settings icon again. And here we can adjust the line width and the dot size as well. So if you increase this, the line gets thicker. And if you increase this one, the dots get bigger. All right. Then let's try using a regression feature by clicking this button over here. Then the trend line will appear as well as the equation over here at the bottom. And this is based on the molecules that are currently selected. So if any molecules are unchecked, their data will not be included in the calculation. So let's try this together. So go to the molecule gallery and deselect one molecule by unchecking it. Let's do ethane. And you'll notice that the dot for that molecule turns gray. And now let's add the regression line or trend line again. And let's see what happens. So the line and the equation changed because the new line was calculated using the molecules that are still selected. So this is a great way to explore how different properties are related and to see how each molecule affects the overall pattern.